We will now use the skills that you have learned in simplifying exponents, in writing and simplifying numbers in scientific notation. Now, what is the meaning of writing numbers in scientific notation? In scientific notation, a number is written using the powers of 10. In other words, use 10 as a base and then raise it to some power to write the number. For example, the number 1392 can be written using the powers of 10 as 1.392 multiplied by 10 to the power of 3. Now, I hope you understand that. Let me see if I can explain that further. Now, you know that 1392 is the same as 1.392 multiplied by 8,000. Is that right? Because you multiply a decimal number by 1,000, move the decimal 3 places to the right, you get 1,392. And 1,000 is the same as 10 raised to the power of 3. So, it's a very simple thing to do to write a number like this in scientific notation. Now, you should always think a number as a decimal number. Now, where is the decimal on this number? It is to the right of 2. Now, to write this number as a scientific number, move that decimal to the left until you come to the right of the first digit. Now, in scientific notation, a number is written with just 1 digit before the decimal. You understand that? So, move the decimal all the way to the left until you come to the right of the first digit. Now, how many places have you moved now? You have moved 3 places. Now, that 3 is therefore the power of 10. So, 1,392 is 1.392 multiplied by 10 to the power of 3. Okay, let's look at other examples. Can you write 186,000? Can you write it in scientific notation? 186,000. The decimal is at the very end. Now, in order to write this in scientific notation, you need to move that decimal to the left. 1, 2, 3, 4, 5. You stop there. You stop at the right of the first decimal. In scientific notation, the number must be written with 1 digit before the decimal. So, you move the decimal here 5 places to the left. Therefore, the number will be 1.86 multiplied by 10 to the power of, what is the power of 10 here? 5, because you move the decimal 5 places to the left. So that will be 1.86 multiplied by 10 to the power of 5. Now, notice that the decimal point comes after the first digit. In scientific notation, the decimal is always placed on the right of the first digit. The power of 10 is the number of places the decimal is moved to the left so that it is placed to the right of the first digit. Okay, let's practice that with more examples. Write 78,330 using scientific notation. Can you try that on your own? Alright, how many places do you need to move the decimal? Remember, always the decimal for a whole number is at the very end. This is where the decimal point is. Move it 1, 2, 3, 4 places so that it will be now to the right of the first digit. That is 7.833 multiplied by 10 to the power 4. 4 because the decimal moved 4 places to the left. Okay, let's now go from scientific notation to decimal form. Numbers written in the normal form is called the decimal form. Now, here I have a scientific form, 8.8 multiplied by 10 to the power 6. Now, we need to write that in the decimal form. That means we must write it in a complete expanded form. Now, the power of 6, 10 to the power 6 means you need to now move this decimal how many places to the right to write it in the normal form. You see, you obtain the scientific form by moving the decimal to the left. Is that right? This number is written in the scientific form by moving the decimal to the right until it comes to the right of the first digit. Did I say the right? The decimal is moved to the left. So the decimal is moved to the left to make this a scientific number. That means if you want to move from the scientific to the decimal, you need to now move the decimal back to the right. Now, the power 6 means this decimal needs to be moved 6 places to the right. And we have only one digit here. That means 5 places are going to be created by putting zeros. That means this will be, the decimal is going to move from here 1, 2, 3, 4, 5, 6 places. It became 8,800,000. I hope you understand the way we do this. Okay, similarly we can write small numbers. Now, so far we were writing big numbers in scientific notation. How do we write numbers that are less than 1? Between 0 and 1. For example, you know that 0.1. 0.1 is 1 over 10. And from the skill that you know from your exponential understanding, 1 over 10 is the same as 10 to the power of negative 1. Is that right? 10 to the power of negative 1 is the same as 1 over 10. Alright, how about 0.01? 0.01 is 1 over 100. And 100 is 10 to the power of 2. So 1 over 10 to the power of 2 is the same as 10 to the power of negative 2. So 0.1 is 10 to the power of negative 1. 0.01 is 10 to the power of negative 2. What is 0.001? 10 to the power of negative 3. Now, I want you to watch this. When you write this in scientific form, how would you write 0.001 in scientific form? In scientific form, the decimal must be sitting to the right of the first digit. Now, how many places do we move this decimal to make this sit to the right of the first digit? You got to bring this 1, 2, 3. So this becomes 1 multiplied by 10 to the power of negative 3. That 3 is the number of places you move the decimal to the right. So 0.001 is 1.0 multiplied by 10 to the power of negative 3. That's how this becomes the scientific form. That means, if If you now look at this, if there are 2 zeros after the decimals, then the power of 10 will be -3. Alright, the power of 10 can be determined by looking at the number of zeros after the decimal. Now, let's look at that again. Here, there are no zeros after the decimal. The power is -1. Here, we have 1 zero after the decimal. The power is -2. Here we have 2 zeros after the decimal. The power is -3. So, how will you write 0.00001 in scientific form? If there are 4 zeros after the decimal, the power of 10 will be -5, and so on. If there are 5 zeros after the decimal, the power of 10 will be -6. Okay, let's try an example. 0.00539. Can you write that in scientific notation? In order to write this in scientific notation, we need to move this decimal now 3 places to the right, so that it comes to the right of the first digit. Now, when you move decimal 3 places to the right, the power of 10 will be -3. So this is 5.39 times 10 to the power of -3. Alright, how about this? 0.000000712. How will you write that? How many places do you need to move this decimal to the right to bring it to the right of 7? Again, let me repeat. In scientific notation, the decimal must sit to the right of the first digit. You must bring it to the right of 7. You need to move the decimal 7 places. Look at this. 1, 2, 3, 4, 5, 6, 7. So that number will be 7.12 multiplied by 10 to the power of -7. I think that's easy now to write numbers in the scientific form. A number in the scientific form will always have 1 digit before the decimal. That is the characteristic of a number in scientific form. Okay, let's do this. Write 0.0000043 using scientific notation. How many places do you need to move this decimal to bring it to where? Where do you want to keep it? You want to bring the decimal and keep it to the right of this 4. So you need to move it 1, 2, 3, 4, 5, 6, 7 places. So that will be 4.3 times 10 to the power of -7. Alright, now I'm giving you a number written in the scientific form. You need to write it in the decimal form. Look at this. The number 6 here tells you that this decimal has to move now to the left. You see, watch here again. To write a number like this in the scientific form, we move the decimal to the right. Now, if you want to go from scientific form to the decimal form, you now move the decimal back to the left. How many places should this decimal move to the left? There are 6 places. That means you got to move 1, and now you got to start putting zeros. 2, 3, 4, 5, 6. How many zeros did I put? 5 zeros. It is easy to remember like this. If this number is 6, that means what? If the number is -6, the number of zeros after the decimal will be 5. So that will be 7.4 times 10 to the negative 6 is 0 point. After the decimal point, there are 5 zeros and 7 4. So the decimal which was originally here moved back to the left 6 places, creating 5 zeros. Okay, let's now do a simplification. Simplify and write the answer in scientific notation. 2.1 times 10 to the negative 2 multiplied by 5.6 times 10 to the negative 5. Now, this is the same kind of simplification we did in the past. Now, what is the thing that we need to do first? First, we write like terms. Look at this. 2.1 can be multiplied by 5.6. They are both like numbers. And then 10 to the negative 2 can be multiplied by 10 to the 5 because they both have the same base. Now, what rule will you use in order to multiply numbers with the same base? You use the product rule. Okay. First, we use the associative property of multiplication. You understand what that property is. Associative property means if you are given numbers to multiply like this, you can multiply them in any order. You don't have to go from left to right. You can pick and choose. So we have chosen to multiply 2.1 with 5.6 first, and then multiply 10 to the power of negative 2 with 10 to the power of 5. That is what associative property means. We can change the association according to our liking. So, look at the way I wrote it. 2.1 times 10 to the negative 2 multiplied by 5.6 times 10 to the 5. I wrote this 2.1 times 5.6. I put the numbers first. And then the base 10, 10 to the negative 2 multiplied by 10 to the power of 5. Well, you know how to multiply these two. What is 2.1 multiplied by 5.6? I want you to do it now. Now, stop the video and do this number and then come back and watch it. Alright? 2.1 multiplied by 5.6 is 11.76. And 10 to the power of negative 2 multiplied by 10 to the power of 5. The bases are the same. What do we do to the exponents therefore? What is the product rule? When you multiply expressions with the same base, you add the exponents. So this will be 10 to the power of negative 2 plus 5. Okay. Now that is 11.76 multiplied by 10 to the power of 3. Now we have a problem. Is the answer in scientific form? You see, a number written in the scientific form must have the decimal to the right of the first digit. Now, this is not in scientific form. Now, how do we make that in scientific form? Alright, what we need to do is write this number, 11.76. First write 11.76 in scientific form. Can you do that? Well, 11.76, there you are, is the same as 1.176 multiplied by 10, isn't it? Yes, 11.76 can be obtained by multiplying 1.176 by 10. You see, multiplying by 10 means move the decimal one place to the right. Now, so I'm going to write this number 11.76 as 1.176 times 10 to the power of 1. 10 is the same as 10 to the power of 1. Let's do that. So, in order to make this in scientific form, we write 11.76 as 1.176 times 10 to the 1. And now, once again, we multiply the powers of 10. So that will be 1.176 times 10 to the power of 1 times 10 to the power of 3 is 10 to the power of 1 plus 3, that is 4. So the final answer is 1.176 multiplied by 10 to the power of 4. Okay, let me ask you, can you write this number in the decimal form? What will you do to write this in the decimal form? This is 10 to the positive 4. You see, when the power of 10 is positive, it signifies a big number. So that means to write it in the decimal form, you need to move this decimal to the right. How many places? 4 places. So this will be, when you move decimal 4 places, it will be 1, 2, 3, and then put a 0. The decimal form of this number will be, what that will be? That will be 11760. This is the decimal form of this number. That should be a problem. If you now want to convert it to scientific form, look at this. Move the decimal 1, 2, 3, 4. It is 1.176 times 10 to the 4. Alright. So you must be very clear about when do you have positive power and when do you have negative power. Negative power is used for numbers that are very small. Positive powers are used for numbers that are very big. Okay, let's move on and do another one. Simplify and write the answer in the scientific notation. Now, see if you can read this. 2.1 multiplied by 10 to the power of negative 2 multiplied by 5.6 times 10 to the power of 5 all over 3.6 times 10 to the power of 6. Now we need to simplify this and write it in the scientific form. Now, what do we do first? Well, first of all, we can write these without the parenthesis. You see, the parenthesis doesn't make any difference at all because all these numbers are multiplied. There is no need for these parentheses. So we write it without parentheses. And look at the next step I'm going to write. I'm going to break it into 2 blocks. Now first I'm going to multiply 2.1 by 5.6 and divide it by 3.6. Now that is my first block. In other words, I'm combining like terms. So what's that again? It is 2.1 multiplied by 5.6 and divide that by 3.6. That is my first term. Now multiplied by, we now deal with the powers of 10. 10 to the power of negative 2 times 10 to the power of 5 divided by 10 to the power of 6. Alright, so write it into 2 blocks. The numbers multiplied by the powers of 10. Okay, now you need to do this. What is 2.1 multiplied by 5.6 divided by 3.6? Can you simplify that? Well, I simplified, I got it 3.27. 3.27. And look at the way I write this block of numbers. Now, previously I told you in the last 2 lessons that an answer must not have a negative power. But that is not going to be true in this case. Now, in this case, when you write small numbers, the power of 10 is going to be negative 2. Now, the rule in this case is a power of 10 should not be sitting on the denominator. That's the rule. When you want to simplify numbers to write in the scientific form, there should not be a power of 10 on the denominator. If you have a power of 10 on the denominator, you must bring it up to the numerator. Now, you know that if an exponent is on the denominator, when you bring it to the numerator, it will change its sign. So this 10 to the power of 6 on the denominator can be moved to the numerator. It will become 10 to the power of negative 6. You understand that? We have been practicing that before. So once again, when you want to write a number in the scientific form, powers of 10 will not be sitting on the denominator. You need to move it from the denominator to the numerator. When you move a power from the denominator to the numerator, the sign of the power will change. If the power is positive, it will become negative when it goes up. If the power is negative, it will become positive when it goes up. So what happened? This quantity I calculated, I got 3.27. And this is now 10 to the power of negative 2 multiplied by 10 to the power of 5 multiplied by this 10 to the 6 went up to become 10 to the power of negative 6. Okay, what is now this equal to? This is 3.27 times. Use the product rule here. The bases are the same, therefore you add the exponents. That will be 10 to the power of negative 2 plus 5 minus 6. There you are. And that will be 3.27 times 10 to the power of negative 3. You see? First add the negative numbers. Negative 2 added to negative 6 gives me negative 8. Negative 8 plus 5 is a negative 3. So the answer here is 3.27 times 10 to the power of negative 3. Tell me, how would you now write this in the decimal form? I know some of you are getting confused with the negative power and the positive power. Now, if the power is negative, to bring it back to the decimal form, you move the decimal to the left. If the power is positive, a positive power is a big number. So, to make a big number, you move the decimal to the right. So, if the power is positive, to convert the number to decimal form, move the decimal to the right. Now, here we have the power negative. That means the decimal has to move to the left. How many places? It has to move 3 places to the left. So that will be 1, 2, 3. There will be 2 zeros after the decimal. So the decimal form is 0.00327. Okay? Alright, let's do one more. Simplify and write the answer in scientific notation. 78,000 multiplied by 0.00054 divided by 0.032 multiplied by 0.0055. Now, you must say, I have a large number here. When you write it in scientific form, the power of 10 will be positive. I have a small number here, small decimal number. Look at this, 0.00. It's a very small number. When you write it in scientific form, the power of 10 will be negative. How about this? The power of 10 will be negative. How about this? The power of 10 will be negative. So, first of all, let's do it in mind. How do you write 78,000 in scientific form? That will be, you move the decimal 1, 2, 3, 4 so that the decimal sits there. It is 7.8 times 10 to the 4. Alright, this, to make it a decimal, to make it a scientific number, you need to move the decimal to the right 4 times. It will be 5.4 times 10 to the negative 4. What is this number? Move the decimal 2 places to the right to bring it to the right of 3. It is 3.2 times 10 to the negative 2. How do you write this? The decimal is moved 1, 2, 3. Move 3 places to the right so that this is 5.5 times 10 to the negative 3. Okay, so first we write each number in the scientific form. And that is 78,000 is 7.8 times 10 to the 4. I hope that's okay. 0.00054 is 5.4 times 10 to the negative 4. 0.032 is 3.2 times 10 to the negative 2. And 0.0055 is 5.5 times 10 to the power of negative 3. And now we do the same thing as we did in the previous case, right? Use associative property of multiplication. Write this as 7.8 times 5.4 multiplied by 10 to the 4 times 10 to the negative 4. You understand that? On the denominator, what will happen? 3.2 multiplied by 5.5 times 10 to the negative 2 times 10 to the negative 3. And now what now? You can break it into 2 blocks. A block that contains all these ordinary numbers and a block that contains all the powers of 10. Or what I have done here is I first multiplied these numbers. 7.8 times 5.4, simplify this. 7.8 times 5.4 is, well, I multiplied, I got 42.12. Okay, and 10 to the power of 4 multiplied by 10 to the power of negative 4, use the product rule, it is 10 to the power of 4 minus 4. And on the denominator, 3.2 multiplied by 5.5. Well, you need to do that on your own. 3.2 multiplied by 5.5 is 17.6. And multiply the powers of 10. 10 to the power of negative 2 multiplied by 10 to the power of negative 3 is 10 to the power of negative 2 minus 3. Okay, what's our next step? Separate this into 2 blocks. The first block is 42.12 divided by 17.16. That's the first block. And the second block is, look at this, 10 to the power of 4 minus 4 is 10 to the power 0. And on the denominator, 10 to the power of negative 2 minus 3 is 10 to the power of negative 5. So one more time. Break it into 2 blocks. The first block is 42.12 divided by 17.6 multiplied by 10 to the power of 0 divided by 10 to the power of -5. What will be the next one? Well, I did this one. Remember, you need to do a lot of work in here. 42.12 divided by 17.6. You need to do that. I got it as 2.39. And remember, in a scientific form, the power of 10 cannot be on the denominator. So this power of 10 on the denominator needs to go up. 10 to the power of -5 going to the numerator becomes 10 to the power of +5. And tell me, what is the value of 10 to the power of 0? Anything raised to the power of 0 is 1. So this is actually 1. And this is therefore 1 over 10 to the power of -5, which is the same as 10 to the power of +5. Alright, there is one more step only for this. That will be 2.39 multiplied by, of course, 10 to the power of 0 times 10 to the power of 5 is 10 to the power of 0 plus 5. This is actually a 1. So that will be 2.39 times 10 to the power of 5 is the answer. You need to develop the expertise to do one like this. Very important. Okay? Let's do another one. Simplify and write the answer in scientific notation. Alright. 0.021 multiplied by 0.00054 all over 552 multiplied by 7,250. Well, the first task is to write each of these numbers in the scientific form. Alright, shall we do that in mind? Okay, tell me, what is 0.021 in the scientific form? To do that, now remember, a small number like this, the power of 10 will be negative. This also. How about these big numbers? The power of 10 will be positive. So, move the decimal 2 places to the right, so that this will become 2.1 times 10 to the power of -2. And what is this? Move the decimal 4 places to the right to bring it here. This is 5.4 times 10 to the -4. Now, this is 552. That will be 5.52 times 10 to the power of 2, +2. And this will be 7.25 times 10 to the power of 3. Alright, let's write that. So the first number is 2.1 times 10 to the power of -2. The second number on the numerator is 5.4 times 10 to the power of -4. On the denominator, 552 is 5.52 times 10 to the power of 2. 7,250 is 7.25 times 10 to the power of 3. Now remember, these parentheses are just to indicate that represent each number. These parentheses really don't have any meaning. Alright, so you can actually remove them. And now what do? Use the associative property to write this as 2.1 multiplied by 5.4 and then multiply the powers of 10. On the denominator, 5.52 multiplied by 7.25 and then multiply the powers of 10 like this. So that will be 2.1 times 5.4 times 10 to the negative 2 times 10 to the negative 4 over 5.52 multiplied by 7.25 and multiplied by 10 to the power of 2 multiplied by 10 to the power of 3. Next, you got to do a lot of work here. Multiply this 2.1 times 1.4, what does that give you? And multiply 5.52 times 7.25. Multiply that. Okay, tell me, what is 10 to the power of negative 2 multiplied by 10 to the power of negative 4? The bases are the same, therefore you add the exponents. What is negative 2 added to negative 4? It's negative 6. So this will be 10 to the power of negative 6. On the denominator, what is 10 to the power of 2 multiplied by 10 to the power of 3? That will be 10 to the power of 2 plus 3, or 10 to the power of 5. Okay, now I multiplied this 2.1 multiplied by 5.4, I got 11.34. And 10 to the power of negative 2 times 10 to the power of negative 4 is 10 to the power of negative 2 minus 4. On the denominator, 40.02 multiplied by, well, 5.52 multiplied by 7.25. You need to check these. Don't just believe my numbers, because very often I make mistakes. But you cannot afford to make mistakes. So 5.52 multiplied by 7.25, I got it as 40.02. Now 10 to the power of 2 multiplied by 10 to the power of 3 is 10 to the power of 2 plus 3. And now split this into 2 blocks if you can. Well, 10 to the power of negative 2 minus 4 is 10 to the power of negative 6. And this is 10 to the power of 5. Now we split this into 2 blocks. Is that right? That will be 11.34 divided by 40.02 is the first block. Multiplied by 10 to the power of negative 6 over 10 to the power of 5 is the second block. Well, what is this? 11.34 divided by 40.02. Can you figure it out? Well, you need to do that. And also one more thing. In a scientific form, the power of 10 cannot be on the denominator. So, in the next step, you need to simplify this, find the value of that, and then take the 10 to the power of 5 from the denominator to the numerator. What will happen? It will become 10 to the power of negative 5. So I did this calculation. I got 0.283 and multiplied by 10 to the power of negative 6, and then I moved this 10 to the power of 5 to the numerator. I got 10 to the power of negative 5. Okay, what is the next step? We can now multiply these two. What is 10 to the power of negative 6 multiplied by 10 to the power of negative 5? Use the product rule there. That will be 10 to the power of negative 6 added to negative 5. Negative 6 added to negative 5 is negative 11. So we now reached 0.283 multiplied by 10 to the power of negative 11. Is that the answer? No. An answer in the scientific form must have the decimal sitting to the right of the first digit. So we need to work on this number. Alright, can you write 0.283 in scientific form? you got to move that decimal one place to the right. So this will become 2.83 multiplied by 10 to the power of, tell me what? 10 to the power of what? I moved the decimal one place to the right so that the decimal now sits to the right of 2. So it will be 2.83 times 10 to the power of, is it positive 1 or negative 1? This is a small number. We move the decimal to the right. That means it is a negative 1. So this 0.283 now needs to be written as, look at the way I'm writing it, 0.283 is now written as 2.83 times 10 to the power of negative 1. Alright, so now this quantity 0.283 times 10 to the negative 11 is 2.83 times 10 to the negative 1. We wrote this in the scientific form, multiplied by 10 to the negative 11. And now one more time, multiply the powers of 10. What is 10 to the power of negative 1 times 10 to the power of negative 11? That will be 10 to the power of negative 1 minus 11. That is 10 to the power of negative 2. So the answer, the final answer is 2.83 multiplied by 10 to the power negative 12. Can anyone tell me, if I want to write this in the decimal form, how will that look? Will this be a very small number or a very big number? Look at that, 10 to the power of negative 2, 10 to the power of negative 12. Actually, 10 to the power of negative 12 is a trillionth of a 1. It's so small. So, it's a very small number. Tell me how many zeros will be after the decimals. How many zeros? This is 12. That means there are 11 zeros. So, if you want to write this in the decimal form, it will be 0.11 zeros and 283. Well, you need to practice simplifying numbers in scientific form because that is a very important part. Now, in sciences, we very often use numbers like this. So you must be thorough with simplifying numbers in scientific form. Alright, now this concludes the 3 lessons that we dealt with: exponents, the operations on exponents, and finally using the rules of exponents to simplify numbers in scientific form. Alright, I want you to practice this, do your homework, and of course do the quiz on this, and make sure that your skills are all up to date. Okay, I will see you for the next part of this unit, which is the study of polynomials. I will see you for that a little later.